Let's start. So Cyrille Waguet, my name, CTO of InContext Technology. So through this presentation, I will show how we use data and AI to respond to the challenges of resilience in industrial infrastructures. So if you can switch to the next slide. First, some words about InContext. InContext is a software engineering company with a mission to make AI available to everyone in the industry. So our customers use AI basically to increase their efficiency and resilience for their operational processes, as well as optimize their business performance. So first of all, to understand how we help our industrial customers manage their infrastructures and become more resilient, we need to understand some principles about resilience. So next slide. So the resilience is basically the ability of a system to avoid or recover from adverse events. So what is required for resilience? The activities are categorized in main areas. First of all, preventing adverse events. It's best if they do not occur at all. So the second would be managing their occurrences. And then the third would be increasing the system ability to put up with changes in its operating conditions. Next slide. So to illustrate this, let us consider the evolution of the performance of a given system. So for instance, let's talk about the railway infrastructure, railway transport infrastructure. It would cover tracks, tunnels, switches, overhead catenaries, and of course the trains themselves. So the performance of the system degrades slowly, typically until some maintenance point is reached. So those points are typically planned in a preventive manner based on the experience or some thresholds values. So when an unforeseen event happens, failure in the train infrastructure, maybe due to some bad weather condition or some external intrusion, so the system performance breakdown. And this performance loss can be more or less severe and last a certain time. So the overall behavior of the system as a response to the changes in the new conditions represents the resilience of the system. The performance loss, this orange area here, is a measure of this resilience. So reducing the loss severity and the duration of the recovery would increase the resilience of the system, which would recover faster with less negative impact. So we apply AI to help companies achieve this goal along three phases, the three phases of the resilience cycle. So different goals are, first of all, reducing the probability of occurrence. The second is reducing the critical consequences. And the third is effectively speeding up the recovery of the system. So we often hear that making this possible at all would require data which is not available. So getting data is surely a challenge, that's no doubt, but data is actually there and can be managed. So we get operational data from business systems, as well as data from sensors attached to a series of assets. For instance, the rails, the devices in tunnels, or attached to catenaries, or even vibration sensors in the train. So the next slide was right. So this data can give us information about the state of the overall system. So as we know, the number of connected devices is drastically increasing, and this gives us the opportunity to capture information from many parts of the system, making it possible to get the overall picture of the system. So as the Gartner Hype Cycle corroborates this idea, the many upcoming innovations will arise from the combination of AI and connected devices. And so that's what we're doing, basically. So InContext provides the capability to deal with resilience challenges. So the key is Next slide, sorry. Yes, thanks. So the key here is to combine data coming from various pieces of equipment, from assets and pieces of infrastructure, with the appropriate AI models across business networks. So that means across all companies involved in constructing, operating, maintaining, or directly or indirectly using the infrastructure which is of interest. So there are many other actors which can be involved in the business network, like various institutions. They all would contribute data or receive information from the AI. So a high-level architecture overview of our system shows how we combine data from business systems. So this data is typically operating data like the track information in the railway industry, the schedules maybe, and this data will be combined with data from sensors, which are put on various pieces of equipment in the field. So these sensors helps us gather information about what's currently happening in real time. So our system applies AI diagnosis and predictions algorithms, either in the cloud or in the edge, depending on the use case, to detect anomalies, categorize defects, evaluate corrective measures, quantify the infrastructure resilience, and predict the system's weak points. So all of this information is provided through dedicated user interface to all involved parties according to their business requirements. So having AI supporting the three aspects of the resilience cycle, which is, as we saw, prevention, action, recovery, helps business networks increase their proactivity, as well as the efficiency and resilience of their operational processes. Resilience, as we all know today, is important as the corona pandemic has shown us. And with the help of data and AI, we can proactively support resilience of critical infrastructures, as well as support the numerous businesses which run around those infrastructures. And as a last reflection on tackling resilience in complex infrastructures, we need also to consider that working in a data-driven manner is also about changing the way we deal with work. So data and AI brings us to think about new ways of organizing our work processes, which we could in some sense call work 4.0. So thank you very much for your attention.
Ja, vielen Dank.